Hi everyone, so I'm going to talk about my reverse engineering project today. So for my reverse engineering project, I chose a toy water gun. I thought this would be interesting because I've always played with them growing up and they never really lasted too long, so I was curious to see the inside of them. So it's a toy obviously designed to spray water. The colors that I got were a yellow and orange and a green and orange, and the material of these were a very thick plastic. They were very lightweight. You could tell just by holding them that the majority of the inside was hollow, and the top part where you would open to fill it with water, that was a more flexible plastic, but otherwise it was a very thick plastic that you could tell, if a kid was to throw it on the ground and things like that, it would withstand some of that. But it was a fairly simple design, super easy to operate, and the pack of 2 water guns was only $2, so not super expensive either. You can see that it has a nice handheld shape. They were fairly small. They were smaller than my hand. You will see the size of them comparative to that in some of the videos and pictures, but I feel like they were marketed more toward kids. It says ages 4 and up, and I feel like in a small child's hand, it would fit perfectly, but for an adult, it was kind of small. And then I chose a water gun just because I was curious about the durability, and I will talk about that as we go through this presentation. So here is a video before I reverse engineered this project.
Okay, so here is a look at my water gun before I start reverse engineering it. You can see I'm currently just using a yellow and orange water gun. The color is not a huge influence on the functionality of this product, but you can hear from me tapping it and just moving it around that it is a very thick plastic and it's very rigid. And there's also some different grooves and detailing on here, and there's a nice handle with some grips, so that would probably be helpful if you are obviously playing in the pool or with water. That can be slippery. There's the trigger here, so you can squirt the water out of the front, and there is this flexible part here for the plastic that you can pop on and off, and you can see some of the parts in there that operate the trigger and the inside of the water gun, so you're able to fill it up.
Into some documentation of when I have reverse engineered this. So you can see here's just a picture of the packaging. Here is when I've started to break it down, and I will discuss how I did this in a video. So you can see it's just opened up here, and then I started pulling out some of the loose parts on the inside. Okay, so here is my water gun now that I've started reverse engineering it. This has literally just been cut in half. So you can see that the inside is just a bunch of different colors of plastic. So the plastic colors clearly aren't important to the functionality, but it does show some of the different materials that are used. So the outside is this yellow casing, and this was very durable, very hard to get into. I literally had to get it cut in half. Then you can see this orange piece here, which is the trigger, was pretty durable, and it's still mostly attached even after being sawed in half, which is pretty impressive. And then right here, this is another thicker piece where you can see that the trigger, when it would be pushed in, this would trigger here for the water to then be coming out of this tube. Now as we move up into here, the plastic does get thinner and it does not feel as durable. So this is the same thick hard plastic, but as you get up in here, this part, you can see the top gets a lot thinner, and then the straw like tubing for the water to go through and then out the nozzle is a lot thinner, and you can see it does not stand up to being cut as well as the rest of the thicker plastic. And then also when I was shaking it earlier before I had cut it apart, and if you look at my first video, this is where I believe that the shaking noise came from. So this wasn't locked into place super well. There obviously needs to be a space for the water to get into the tube, but if there is where this tube falls out of place, or for some reason is punctured by a piece of plastic or something like that, then that's where a lot of your problems, I think, would come in from the water gun, because this seems to be the cheapest spot in the water gun, is this plastic here, and this is essentially how the water ends up getting out of the tube, or out of the water gun. can see here are some of the pieces removed. The outside was a very thick plastic and it was very durable, very hard to get into. It would definitely withstand being thrown around in a pool, thrown on the ground if kids are running around with them. So I can definitely see why the designers of the water guns chose to make that plastic very thick and very durable. Although as you got inside the water gun, while I was impressed with some of the pieces here with the trigger, that was very durable, very locked into place, and even after it was cut in half, there's pieces that are still attached. So that part is very durable, but as it moves up into where the water would be pumped into and out of the nozzle, that's where I felt like a lot of the potential problems with the water gun would occur. Like I mentioned, you could hear the shaking where this blue piece here that held the straw into place right about here wasn't locked into place. It was shaking around, moving around. So if that, you're running around with a water gun and it pops out of place or something happens, then it's not going to work. And unfortunately, this is not an item that you can repair. As you can see by how hard it was for me to get into this for this project, it's not something that can be fixed. So unfortunately, once it's broken, it's broken. And due to the type of plastic that is used, it would just be thrown out and end up in a landfill, which is not very economical. So for some insights and improvements about the durability and the engineering of the water guns, they overall were more durable than I anticipated. I just picked up a cheap water gun. I knew I would be cutting it apart, so I got 2 water guns in a pack for $2, and so I expected them to be pretty cheap. And I was impressed by the outside, and as I mentioned, most of the inside was also fairly well designed. But there is that slight room for improvement to use some more durable materials for the tubing and to hold that into place. But overall, the design was simple to use, and I could go through the pieces and understand maybe not the technical terms, but I could understand what each piece in the design was designed to be used for. As far as comparing this to other models, I wonder what the differences would be if I bought more expensive water guns, and if the inside materials would be more durable, if the design would be more complex, rather than just a simple trigger and going through a tube. There's the different types of triggers that water guns can have. Some of them have a pump, some of them just have the trigger, and so those can be different as well, that I wonder if that would impact the durability of the water gun withstanding over a long period of time. As far as some improvements, using the same durable plastic throughout the whole inside of the water gun, I think would help make it be more durable, but I also wonder if a similar durability, but if a different plastic could be used. Therefore, once a water gun is broken or being thrown away, then it doesn't just end up in a landfill. It could be something that would be recycled. So that is my reverse engineering of a water gun. I hope you all enjoyed, and I'm excited to see everyone else's. Thank you!